If you remember from example 6.8 from last week, we talked about the design for the reinforcements. However, we just skipped how we can calculate the concrete cover necessary for the section. Just for a quick recap, if you remember, we had the concrete grade C40 4050, which gives you the um, concrete strengths. The concrete strengths will be a 40 megapascal, and the characteristic strength of steel is 500 megapascal. The nominal maximum aggregate size for your concrete is 20 millimeter. It will be used in some tables in the later slides. The diameter of main tension steel, which is in the bottom of your section, will be 32 millimeter, and at the top of your section, it's 20 millimeter. And the diameter of shear links, which surrounds the longitudinal reinforcements, is 10 millimeter. The exposure class is XS1, and the minimum requirement standard for fire resistances are 60. Today, I'm not going for fire design. I'm just concentrating on concrete design based on Eurocode 2. And the intended working life for this structure is 50 years, which is usually the case for building structures. And with these data, we want to go to the Eurocode and see how much cover or minimum cover we need for our section. If you go to the Moodle, and you will see that in the resources and material, you will see there are two files, Eurocode 2, and this is UK National Annex, EC2. I'm talking about these two today, Eurocode and National Annex. So for some parts, Eurocode, when you read Eurocode diverts you to National Annex, which gives you some parameters specifically for the UK region. If you go to the Eurocode standard in page 49, section 441, you will see these two formulas. Formula number 41, which gives you the C nominal, which means nominal cover you need for your section, has two terms, C min plus delta C deviation, DEV. And you have formula 42, which gives you the C min, and the C min is maximum of some other parameters, as you see, C min B, C min duration, plus three sort of different delta C and 10 millimeters. So you need to calculate the first, pick up the first term and the second term and the third term. Between these three, you should find maximum and find C min, then put the C min in the above formula and also put delta C dev and come up with your C nominal. So you can find these formula in page 49 in Eurocode 2, part 1, and all in one. If you take a look at these two formulas, simply you have 6 different parameters, haven't you? So we need to go each by each to derive these 6 parameters and just put them inside these formulas to come up with C nominal, the nominal cover you need for your section. And for this purpose, I start with these 3 different sort of delta C duration, comma, gamma, delta C duration, comma, steel, ST, delta C duration, comma, add. So if you take a look at here at the bottom of this page, you will see that when Eurocode or every other standards give you a formula, the definition of the input parameters are just below the formula. So if you take a look at this part of the screen, below equation 4.2, you will see the definition of these three parameters are referred to section 4412, 4412, and 4412, but the subsections of 6, 7, and 8. So you just need to go to Eurocode. We are here at section 4411. So the section 4412 should be the next page, something like that. And you go there in page 51, Eurocode 2. These are the subsections 6, 7, and 8. And you will see that these three delta are recommended to be 0. However, this recommendation is done based on the Eurocode, but it says also that the value of this delta for using a country may be found in its national annex. So UK has a national annex. The recommended value without further specification is 0. So if you take it 0, you're complying with the Eurocode. But just to be more compatible with UK standards, you need to check these three parameters in national annex. So I already put UK national annex for it's a complementary form of information to the Eurocode 2. You can find it in on Moodle in resources and materials section. And if you go there, this is coming from UK National Annex page 3. You will see that in this column, in the first column, it's rotated for 90 degrees for the publication purposes. However, you can just bend your knees somehow, and you can see in this section it refers to the parameters for section 4412 of the Eurocode. So it's in ascending order, so you can simply find your section of interest and just go there. And you can see these three deltas are recommended to be 0. So this is in agreement with what you see in the Eurocode. However, in some other parts, not here, I mean, in some other design purposes, when you see something in Eurocode and it recommends that you need to just go to the your country's national annex, there might be some differences between what Eurocode recommends and what you see in the national annex. So wherever it refers to you to the national annex, it's good to go to national annex and get the parameters compatible with your country's specifications. So this is not the case here. What it says in the national annex is identical to what the Eurocode says, and all of these three parameters are 0. So far we know that these three parameters out of those 6 parameters are 0, and we need to go for 3 more parameters to be able to use the cover formula, what the concrete cover we need for our section. For that purpose, the next parameter is Cmin. If I just go back to the formula just to show you that we have 2 sort of Cmin, 1 Cmin or 3 one. Cmin B, Cmin DUR, and Cmin without anything. So we have actually Cmin is this one, so we need to calculate Cmin B and Cmin DUR and also this delta. So I just go to the next slide, and for calculating the Cmin DUR, we need to see what's our structural class. And if you go to page 50, again, you have a table 43N, and at the above of this table, it says that the recommended structural class design working life of 50 years, which is mostly always the case for buildings design. The structural class is S4, but it can be different, decreased or increased based on this table. So if you go to the table for the first column, you will see that uh, based on the strengths class of your concrete, you should find your strengths class, which is in this case, for this example, is 4050. You should reduce your class by 1. So by default, it's S4, and based on this table, you reduce it by 1, you will get S3 for your structural class. And if you go to the next page of the Eurocode, page 51, you have the next table, table 44N, and for your structural class, which is S3, and also for your exposure class, which is XS1, it is given by the example, and you will come up with C mean DUR equal to 30 millimeter. For the exposure class, it is given by the definition of the problem. However, there is another table in Eurocode to determine which exposure class you have. And if you remember, you had it in structural design when you define that which part of the environment or city your structure is supposed to be, how close you are to the seashore, or how much rain you have in the region. So if you're not provided with exposure class, you should go to that table and get your exposure class based on the environmental effects. Anyway, here, based on the structural class and exposure class, we see that the C minimum duration, C min DUR, is equal to 30 millimeter. So this is our fourth parameter, and we go for the next one. So this is the 30 millimeter we got for the C mean DUR. The next parameter, the fifth parameter, is C mean B. You can find it in page 50 again in Eurocode. Table 4.2 gives you the minimum cover, C mean B. And it's a very simple table. It says that if you're going to find your minimum cover C mean B, and there are just two cases, separated or bundled. Bundled means you're making a group of rebars and to put in your section, which is not your case. You're putting rebars individually at the bottom and top of your section. So you are in the case of separated, which means that the C mean B is equal to the diameter of your bar. So because you have the rebars of 32 millimeters at the bottom, the C mean B will be 32 millimeters somehow. At the last line, it says that if the nominal maximum aggregate size is greater than 32 millimeter, it's not our case, the C mean B should be increased by 5 millimeter. So it means that if you have very large aggregates, so you should increase your C mean B by 5 millimeter, whatever it is. So for this purpose, you already have C mean B equal to 32 millimeter. And this is for the last parameter, the sixth parameter, which you can find in page 52 of UK National Annex again, page 3, the same page we talked about earlier. And here it is, delta CDEV is equal to 10 millimeter as a constant for everything. And here we are, we have all the parameters all to put together and come up with the minimum cover we need. So this is the equation 4.2. The C mean can be calculated based on the maximum of these three parameters, 32. This is 30, and this is 10. So the maximum of these three numbers will be 32 millimeter. Then you put your C mean here, 32 plus delta. This delta is the deviation based on the actual erection of your structure, and it's always 10 millimeter. It means that it's the mankind error you can do when you put those um, reinforcements in place. It means that if we say it's 32, it's not enough, because one worker may put the reinforcements 10 millimeter below what it should be, where it should be. So this 10 millimeter is a tolerance that should be taken into account for the human errors in practice. So if you add up 32 and 10 millimeter together, you come up with 42 millimeter. And this is what you really need for your nominal cover. And as I said before, you can round it up to 45 millimeter as your nominal cover. And afterwards, you know the rest of the discussions. We did it last week, if you remember. This is the nominal cover you need, which means from the top of the concrete to the first molecule of the steel, or from the bottom of concrete section to the first molecule of your steel. And the first molecule of your steel is the top of your shear link, not the longitudinal reinforcement, as you see here. This is what in practice you will make. And the top of your shear links, you would pour the concrete afterwards in this. And from the top of the concrete to the top of the shear link will be the nominal cover. So for that purpose, for example, D2, which measures from the top of your concrete to the middle axis of your reinforcements, should be the nominal cover plus link diameter plus main diameter at the top of your section divided by 2. So some sort of, I can say that this main diameter talks about the longitudinal reinforcement at top of your section. And if you want to calculate the D parameter, it means that the whole height of your section minus the nominal cover minus the shear link diameter minus half of the main diameter means the bottom reinforcements in your section. So this main diameter is the bottom reinforcement, and this main diameter stands for the top reinforcements, longitudinal reinforcements in your section, and the link diameter stands for the transversal shear reinforcements that you can see. These are shear reinforcement. These are shear reinforcement, and these are longitudinal reinforcements, right? So you can now go to proceed with the design we talked about last week and find out about how suitable your concrete section is. Thank you for listening.